Hello everyone. Let's continue what we learned in part 1 about discrete probability distributions. And if you have not seen the first part, please make sure to check it out first before proceeding to this uh, video. Again, this is a topic that is common to both standard level and higher level of IBDP maths analysis and approaches. Let's try to remember what we discussed in part 1. So let's take a look at this example. So the random experiment is tossing two coins. And as you can see, the random variable that we are focusing on is the number of heads. By the way, your random variable can also be number of tails. Okay, so looking at this tree diagram, we have a total of four possible outcomes: head, 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 tail, tail, head, and tail, tail. And since we are after the number of heads, so we have here 2 as the value of the random variable because we have 2 heads in this outcome. The value here is 1 because we have 1 head in this outcome. In the same manner, the value here is 1 because we have 1 head in this outcome. And lastly, we have 0 because there's no head in this outcome. And then we have the probabilities. So out of the 4 possible outcomes, the probability of x equals 2 is equal to 1/4. So it's 1 out of the 4. The probability of x being equal to 1 is actually 1/2, 1/4 plus 1/4, because we have 2 out of the 4 outcomes. And probability of x equals 0 is 1/4. Again, 1 out of 4. Now we can summarize that, we can tabulate that um, by having this probability distribution table. So the first row, you have here the values of the random variable, and the second row you have the corresponding probabilities. So if you look at this, if you get the sum of all the probabilities, 1/4 plus 1/2 plus 1/4, that is equal to 1. And this actually gives us this very important concept. So for each random variable, there is a probability distribution. The probability of any given event, P sub I, lies between 0 and 1 inclusive. This is a very important concept of probability. Probability should only be between 0 and 1 inclusive. And this one is telling us that the summation of P sub I, the summation of the probabilities, is equal to 1. So P sub 1 plus P sub 2 plus P sub 3 and so on and so forth up to P sub n is equal to 1. So this concept will help us decide if the probability distribution is valid or not. Now let's take a look at this example. Is letter A valid or not? What about B? Is it valid or not? So let's take a look at this probability distribution. So we can do that by getting the sum of the probabilities. So what do you think? Letter A is not valid because 0.2 plus 0.3 plus 0.4 plus 0.2 is exceeding 1, exceeding 100%. So the total sum of the probabilities is not equal to 1. What about letter B? If you get the sum of the probabilities, zero point 0.3 plus zero point 0.4 plus zero point 0.5 plus negative zero point 0.2, it is equal to 1, but it is not valid. Why? Because a probability should only be between 0 and 1. So there's no such thing as negative probability. So the probability distribution of a discrete random variable can be in table form, just like what we had in the different examples. Now, it can also be in graphical form using a probability histogram, and it can also be in functional form. So we are going to take a look at the functional form. So aside from a table form, it can also be in function form. So you remember f of x, but this time we're going to use p of x. P stands for probability. It's just a common notation for probability function. So let's take a look at this example. Okay, so we have this probability function p of x is equal to x squared plus 1 over 34 for x equals 1, 2, 3, and 4. Now, is this valid or not? Okay, so what we need to do if we want to construct a table, so we can just plug in 1 to x. So if we do that, we will get 2 over 34, okay, when x is equal to 1. When x is equal to 2, which is one value of the random variable, plugging that in our function will give us 5 over 34. So do that in all of the values and then check if the sum is equal to 1. So this is a valid probability distribution because the sum of all the probabilities is equal to 1. 2 over 34 plus 5 over 34 plus 10 over 34 plus 17 over 34 is equal to 34 over 34. Let's move on to the next example. So our probability function is defined to be a combination of 3 taken x, 0.6 to the power of x times 0.4 to the power of 3.3 minus x. So we will do the same thing wherein these are the values of the random variable. So plug those in our function to get the corresponding probabilities. And this is what we get. And you get the summation or get the sum of all the probabilities. If it is 1, then it is a valid probability distribution. Okay, so now let's go to the second example, question number 2. So Sally's number of hits each softball match has the following probability distribution. Now state clearly what the random variable represents. So this is our table. Now, what is the random variable? Okay, if your answer is the number of hits, because that is in number form, numerical, it could either be 0, 1, 2, 3, 4, and 5. So that will be our random variable, the number of hits. Now, how will you find the value of k? How will you find this value of k, which is the probability of x equals 2? So we know that the sum of the probabilities must be equal to 1. So we can do that by adding 0.07 to 0.14, 0.46, 0.08 plus 0.02 plus k, and it must be equal to 1. So you will have this equation and solve that simple equation. You will get k is equal to 0.23. So that would be the value of k. Now let's go to letter C. What does it mean by probability of x is greater than or equal to 2? Meaning this will be equal to the probability of x being equal to 2 plus probability of x being equal to 3 plus probability of x equals 4 plus probability of x equals 5. So you will have this 0.23 plus 0.46, which is probability of x equals 3 plus 0.08, which is probability of x equals 4 plus 0.02, which is probability of x equals 5. Add them all up and then you will get 0.79. Now you can also answer this by subtracting 1 to the probability of x equals 0 plus probability of x equals 1. You will get the same answer anyway. Now what about probability of x more than or equal to 1 but less than or equal to 3? So for you to get this, you will have to get the sum of the probability of x equals 1 because that is inclusive, plus probability of x equals 2 plus probability of x equals 3, which is 0.14 plus 0.23 plus 0.46, and you will get 0.83. All right. Now let's have this next example. A discrete random variable x as probability distribution given by p of x is equal to k times 1/3 to the power of x times 2/3 to the power of 4 minus x, where x is equal to 0, 1, 2, 3, and 4. So find p of x for x is equal to, for all of the values of the random variable, and that is for you to come up with the table. And then b, find k, and hence find p, the probability of x greater than or equal to 2. So your answer should look like this. Okay, so when you plug in all these values to the function, you will get 16k over 81, 8k over 81, 4k over 81, 2k over 81 when x is equal to 3, and when x is equal to 4, you will get k over 81. So these are the probabilities. And you know that the probability that the sum of these probabilities must be equal to 1. So that will help us to find the value of k. So solving this equation, you will get k is equal to 81 over 31. So for you to find out the specific probabilities, plug in the k 81 over 31 to the k in each probability. All right, and that will help us to answer the next question, and that is, what is the probability of x is more than or equal to 2? And you can get this by getting the sum of the probability of x equals 2 plus probability of x equals 3 plus probability of x equals 4, and you will get 7 over 31. All right. um, just like what I mentioned in the previous slide, you can also find the value of the probability of x is greater than or equal to 2 by subtracting 1, which is 100%, minus the probability of x is less than 2. Okay? And you will get the same thing, 7 over 31. All right, so that's it for now. Okay, I don't want to overwhelm you with so much concepts. Now, the next two slides will be your assignment for you to try out. Okay, so this one is very similar to the example that we discussed in part one, but I just changed it a bit. And then this one is another thing that you should be working on at home to practice for practice. And then next time we will discuss the answers. Okay, so bye for now, everyone. Please stay safe and healthy.